Hello everyone. Today we're diving into transport layer services and comparing connection oriented versus connectionless communication. So by the end of this video, you'll understand their differences, strengths, and real world applications. So let's get started. So the transport layer plays a crucial role in network communication. It ensures that data is transferred between applicants running on different devices over a network. It also provides error detection, flow control, and congestion management. So there are two primary protocols that are used in the transport layer. So one is connection oriented protocol and the other one is connectionless protocol. So connection oriented protocol ensures reliable and ordered communication, and connectionless protocol, it provides faster best effort data transfer without guarantees. Now let's move on to slide. Next slide. So connection oriented service. Now let's talk about TCP, or Transmission Control Protocol. So this establishes a connection before transmitting data. This is done using a process called three-way handshake. So SYN, which is the sender requests a connection, SYN ACK, the receiver acknowledges the request, and ACK, the sender confirms the connection and data transfer begins. And because of its reliability, TCP ensures that the data arrives in the correct order without errors. So this is commonly used for web browsing, HTTP, HTTPS, email, file transfers, etc. Let's move on to the next slide. So now we come to connectionless service. So unlike TCP, this does not establish a connection before sending data. It simply sends packets regardless of whether they are received correctly or in order. That's why this makes connectionless more faster and more lightweight. However, it does not guarantee delivery, ordering, or error correction. So because of its speed, connectionless or UDP, it is ideal for video streaming like Netflix, YouTube, Amazon Prime, online gaming, or Google Meet, WhatsApp calls, Zoom, Skype, all of these sorts. So let's move on to the next slide. So the next slide shows the key differences between TCP and UDP. So as far as reliability goes, TCP guarantees data delivery while connectionless or UDP does not. Speed TCP is slower due to error checking and UDP is faster with minimal overhead. For ordering, TCP delivers packets in order but UDP does not. Overhead, again, TCP has a higher overhead and UDP has a lower overhead. Use cases. TCP is used for file transfers, emails, and web browsing. UDP is used for real-time applications like video streaming, gaming, etc. Okay, so now let's go over some of the advantages and disadvantages. So advantages of TCP. This ensures reliability, data integrity. It guarantees that everything is delivered in order and correctly. But some disadvantages obviously are it is slower due to acknowledgement and retransmissions. It has to make sure everything is in order and all the data is correctly delivered. And it also has higher latency compared to UDP, which is connectionless. And let's go on to check the advantages and disadvantages of UDP. So UDP is faster, it has low latency, minimal overhead, which is ideal for real-time applications, which we discussed before, which is online video streaming, gaming, etc., or even Skype, Zoom calls, like that. And the disadvantages are that there is no guarantee of packet delivery. They may arrive out of order or even be lost. So if there is any critical data transmission required, UDP is not suitable. We should go with uh, TCP instead. Let's go on to slide 8 now. When should you use TCP and when should you use UDP? So let's go over that now. When we want accuracy, reliability, when accuracy and reliability matter more than speed, then for example, like in web browsing or file transfers or emails, we need to make sure the emails are sent accurately, correctly to the right receiver. So for these applications, TCP is ideal. And UDP we can use when we're streaming. We need speed, we need low latency. for online gaming, online calls, Netflix, YouTube. That is when we can use UDP. Now let's go over some of the real world applications of TCP and UDP. So for TCP, as we discussed, web browsing, file transfers, email services, and UDP is video streaming, uh, online calls, online gaming, DNS queries. And understanding these differences helps in choosing the right protocol based on application needs. So in conclusion, let's wrap it up. The transport layer ensures seamless communication between applications, and TCP provides reliability and error correction, which is ideal for data sensitive applications. TCP gives accuracy and data um, privacy or protectivity the highest priority, which is very crucial for some applications. And UDP prioritizes speed and efficiency, which is perfect for real time applications. And thank you for watching. If you have any questions, you can leave it in the YouTube video down below, which will be posted. Thank you.